All right, let's actually go like that so that it's not getting all rumbled in my hoodie there. So, all right, everybody. So I'm Mike Villiger. I'm actually here from Dynatrace. We were a somewhat late addition to the lineup here for this show. We actually ran into Luke a couple of weeks ago trying to line up some folks for some of our user conferences that we had coming up, and he's like, "Hey, I'm doing this spring thing in Toronto," and I'm like, "Cool, I've never been to Canada, so let's do it." So I hopped on a plane from Chicago yesterday, and here I am. So one of the things that I wanted to talk about, and you're going to get a little bit of repeated content here because when people talk about pipelines, we tend to talk about, generally speaking, the same things. But I am going to kind of dive into a little bit of the why, just to kind of set the stage. I haven't really seen a lot of that today. But then towards the end, assuming I pace myself properly, towards the end, I'm actually going to give you a little bit of a live demo / walkthrough on a sample set of linked Jenkins workflows that actually outline what it is that I'm talking about. So you'll be able to kind of see how they end up looking. So once again, so I'm not sure if anybody's heard that phrase before. Software is eating the world. I like to, at this point now, kind of poke fun at a lot of the various phrases that everybody seems to put in their decks nowadays. So it's actually kind of here in a humorous fashion. But even Pivotal actually recently had a blog post linking to something saying, hey, 5 years later, software really is still eating the world. So one of the things that we like to talk about is digital transformation. Is anybody kind of familiar with the concept? Have they heard the term digital transformation before? So got a couple of hands raised. So when we look at what's happening in various longly entrenched industries, they're getting upset by various other companies kind of coming into their space, doing things in a different way, generally speaking, doing things in a little bit more of an agile fashion. I apologize that some of these images actually kind of look iffy. I'm not sure there's scaling issues going on here, but there was one particular bank that realized that they, in order to be competitive, they had to actually become more of a digital organization, become a digital bank, and a lot of the things that they were then doing via mobile apps could conceivably replace some of the things that are being done by tellers and so on, right? And then when we talk about disruption, right? Anybody remember Blockbuster? Do they have Blockbuster in Canada, right? So, yeah. So, I can't tell you how many times I ended up having to pay some extraordinarily like $90 value for a tape that I lost when I could go to the store and buy it for $20. But, so obviously they were disrupted by Netflix. I had a great conversation with my taxi driver on the way from the airport. So obviously UberX is not allowed to pick people up at Pearson. And so I got into a conversation with the taxi driver about that, and he was militantly opposed to the mere existence of Uber in this city. He's convinced that it's going to completely collapse the taxi industry, and then everybody's just, bodies are going to be littering the streets as like all these Uber drivers are crashing into each other and pedestrians and so on. But it's another example of a long-standing industry that was disrupted by a newcomer. So, there's a great quote here that by the end of 2017, 2/3 of the CEOs of the Global 2000 enterprises will have digital transformation at the center of their corporate strategy, right? So digital transformation is basically a lot of these elements that things like Pivotal Cloud Foundry and Spring and so on are enabling these folks to do. In my customers that I talk to, I see a lot of like, okay, using Spring Boot, Spring Cloud, and so on, creating application templates so that all they have to do is clone a Git repo and then spend a couple of minutes coding their business logic, and that's that. We don't have to worry about all the other elements anymore. So we start talking about this digital transformation that's taking place in these organizations. So how do we change? Well, I'm going to walk through a couple of examples here. So here's a great example of what we'd call a legacy pipeline, right? Anybody remember what that is? Right? Disposable camera. So you've got this disposable camera. You use it to take a couple of pictures, right? 24 features are in that box. You have 24 exposures in that roll of film, right? So you ship the whole box, all 24 of those features at once, and then you get it delivered, and now you get your feedback very late. Now, if it's going to be kind of hard to see for some of the folks in the back, but it's just an example of a really terrible picture with a baby making a really awkward face. So you end up frustrated, right? It's just it's a really poorly performing pipeline. You're not getting feedback until a couple of weeks. Maybe at best, I think the best development time was usually like an hour towards the end of film development, right? It was like, okay, you take 96 exposures, send them off, get them developed, and an hour later you know whether they're screwed up or not. So here's an example of how we kind of take that same idea now in the more modern slant on that. So we have our iPhone. We're basically doing one feature at a time, right? So we have one picture at a time. We're applying filters to that image, so we're able to optimize that image before we deploy it. And then by using Instagram and Facebook and so on, we have instant feedback from our customers of that feature that we deployed. And we're able to iterate over this, one image at a time if we so chose. And so one of my coworkers, Andy Grabner, that actually does a lot of talks on this particular topic, has, I believe, coined this phrase, continuous innovation and optimization, right? So as we basically take the idea of innovation and improving our software via optimization, and we actually make that a process that's ongoing as part of your pipeline. And we'll get to a couple of elements later that it's not strictly speaking limited to fixing bugs and so on and so forth. There's actually a little bit more to it. So not sure if how many of you were actually at Spring One Platform? So the Pivotal guy was. You were at Spring One Platform. So actually, a lot of people weren't there. Okay. So Spring One Platform was a really, really great conference. So obviously, hopefully everybody can make it out there next year. But everybody at my company was really moved by Ansi's talk. It was amazing. It was delivered extremely well. And it's really relevant to everything that we're talking about. So it's basically the very similar topic to what I'm actually speaking about today. So in the old days with waterfall and so on, you had a lot of I'm going to actually go to this one instead. So you had a lot of these gaps between your ability to deliver value and your opportunities to actually kind of pivot back around again and take a different approach. Whereas what we're trying to talk about nowadays, right, is to do this process continuously, right? So we're taking some risk out of the out of the software development and product delivery process. We're taking some risk out by being able to deliver those changes a lot more quickly, and by being able to constantly collect information from our customer base as to whether or not that feature that we delivered was what they actually wanted. And then obviously, something like Cloud Foundry and what have you is a key element towards making that happen. All right, so now we've got the next kind of meme-esque thing. All right, so how many people are here that are familiar with the concept of a unicorn? Right, there's a couple of different concepts of unicorns. Right, so we got a couple of little like hand wavy things. So obviously, in technology, there's the unicorn that's talking about stock market valuation. That's not what I'm talking about here. In the DevOps community, the unicorns are the folks that are actively delivering software in via an automated pipeline in a very rapid way, and they're basically the folks that everybody is aspiring to be, and that's kind of the impetus behind this particular picture. I don't think that's what the artist was originally intending, and that's actually the link there to, you can get that on T-shirts and stuff like that. But the whole idea here is that maybe you're not using DevOps processes yet, right? So we're rhinos, right? We're not doing it yet, but we're all kind of on that treadmill, kind of trying to become unicorns. So let's talk about some statistics from a couple of these unicorns, right? So one of the key things to remember here is it's not just about like blindly deploying technology quickly. What we're trying to do is we're actually trying to deliver value, right? And we're trying to deliver that value at the speed of business, right? So one of I don't know why I keep smacking the microphone. One of our customers, Cars.com, they were kind of, this is probably a little bit of an outdated statistic, but when we got this figure from them, they were delivering about 700 deployments a year. Then we look at some of the other organizations out there like Flickr, they're doing 10 deployments a day. Etsy's doing 50 to 60 a day. And then, the crazy people in the room, Amazon, are doing one deployment every 11.6 seconds, right? And that's actually probably an outdated figure as well, because it's, I believe, a couple years old. So some more specific information that was collected at some conferences. We talk about Target, right? Not necessarily an organization that you would think about when it comes to cutting edge technology, but they went from having monthly releases to doing 80 deployments a week, right? And then the key things to remember is that if you follow the right practices and processes when you're doing this, over 96% of their deployments are successful. So you'll see a link kind of at the bottom here. I'll make sure to get the deck out to everybody. But my coworkers, Andy and Brian Wilson, actually do a podcast about performance elements and things like that. And they had the senior director of DevOps on the podcast a couple of weeks ago, talking about some of the things that they do there. So, one of the things that they've done is they've implemented performance counters in their CI/CD pipeline, which is kind of given them the ability to deploy things a little bit more rapidly. And really the key there is to be able to have some assurances that there's going to be a high level of quality with all of these deployments that you're doing. So, and it's enabled a bank, to actually take some of these deployments and be pushing them out into the public cloud as well, which is pretty astonishing. And then, Dynatrace as an organization, we're in the midst of our own digital transformation and our own, shift to DevOps practices and so on. Back in 2011, we only had 2 major releases a year, right? The vast majority of our customers were getting a piece of software that was shipped to them, and they were running that on-prem, right? Now we have a SaaS and managed product that is, receiving over 170 deployments a day. And we're actually running this product with no ops team, right? So it's literally there's no folks that are specifically, tasked with the care and feeding of this environment. It's a straight DevOps team, and there's nobody that's a dedicated ops person there. Yes, sir. There's a question.
So, if you're having so many deployments in a day, not necessarily your company, but any other companies out there, even Amazon, is it because of not the proper planning, or because of the requirements even they're changing so fast, or the incidents? Like what exactly the core?
Yep. So the question was, what is some of the reasoning behind having such frequent deployments? And the answer to that question is really it depends. Every organization is going to have their own reasoning behind a deployment, right? It might be a bug fix. It might be a new feature. But the other thing is that when you start to do some of these things, and we're going to get to this in another slide, one of the big things that you do when you start implementing these pipelines and this whole way of doing things is you do away with big bang releases, right? So you no longer have your giant deployment of the entire product front to back. You're only deploying that one fix towards that one little piece of code, right? So it's it's really, you're kind of shifting that paradigm, that paradigm on its head. So I had something else that was in my head about that, but I lost it. So when we kind of get through some of the other things, you'll see a little bit more, and I think it might start to become a little bit clearer, because I'm about to give an example from one of our customers as they went through kind of redesigning their application to cope with some of their growth. So, so not every sprint ends without bruises. I'm not sure if anybody remembers that from the Olympics. So I've got kind of an example of somebody that did have a little bit of growing pains when they started to kind of go through their transformation. It's a customer of ours by the name of Prep Sportswear. So they are an organization out of Europe, and in 2013, their business demanded that they go from monthly to daily deployments. And once again, this was basically the ability to get features out into the system quicker, right? And the other thing that I was thinking of that I lost for a second came back to me. So with a lot of these web shops and stuff like that, you might think, okay, well, they're doing 80 deployments a day. A deployment might be something as simple as pushing a new image, right? So it's not, it's not necessarily, by splitting things up and having that ability to push things out quickly, it allows you to really divvy up what it is that you're pushing out there. So sorry to briefly digress. So when this organization here started to make that shift, right, from those monthly to those daily deployments, they found that 80% of those deployments failed. So, when you basically end up having, instead of having, say, 25 deployments, now they end up having, basically barely any better than they were before, since they were having so many failures. So, basically what they started to kind of triage the process, right? So they found, I'm going to click through here because it's more fun when I've got the image. All right, awesome. So just because I really like the image. And if you notice here, that there's the color there is really important, because the stuff going into the hopper is brown. So just kind of keep that imagery in your head. I'm gonna come back to that again later. So as they were going through their triaging why things were kind of going wrong, they realized that they had over 4 million lines of code, and most of the documentation was in Russian, and they weren't actually in Russia. So it was kind of became an interesting support issue there. And then obviously, once again, to kind of tie together with that, the folks that actually wrote all those Russian comments, they weren't there anymore. So, I had a conversation with this gentleman over here this morning about, trying to come up with some, good quality code is code that's easily maintainable, right? So this is an example where this organization had code that was not maintainable due to obviously, many reasons. But some of the code itself was actually written in Russian. So you basically just had this situation where, unless they hired a bunch of Russian developers again, they just weren't going to be very successful. And then obviously they had a lot of monoliths involved, and basically big huge servers with no isolation between applications. One server might be running 6 different apps on it, with no isolation. I mean, it was the early days of containers, the days before containers were widespread. And then the other thing obviously was there was no automated testing in their pipeline at all. So, obviously, we've been talking quite a bit, in the Ontario Teachers Pension Plan conversation earlier today was basically, the whole point of this is to automate everything, right? Because the whole idea is that you don't want anything that's not reproducible without a human being involved. And then once again, since their pipeline didn't have any testing, all that stuff at the beginning there, it just made it into production. So they started to kind of rethink things. As they looked at what kind of happened, this was an example of an organization that saw some pretty explosive growth. They started as a two-man team, and in the beginning things were kind of slow going. It was just kind of a side project kind of thing, but eventually they started to get some perception out there in the marketplace, right? So they've managed to get some pretty significant expansion to their user base, but then they found that there was a disproportionately increasing response time as well, right? So this is an example of a extremely poorly scaling application. And then so I'm going to go back to that again there. So obviously the projection there then would be that as the response time is starting to increase, the number of users is going to decrease because we all know we're not going to sit there and wait 30 seconds for a page to load. So in the beginning, right, 2015, their monolithic application, this is a Dynatrace screenshot, by the way, just in case anybody was curious. In the beginning, they had half a second response time, but as they started to get busier, that had gone to 2.68 seconds. But if you look here, the CPU utilization on their app servers was starting to get pretty out of control. So they decided to kind of rethink their architecture approach, because with CPU bound, scaling vertically, it was an application that didn't have a lot of capability to scale horizontally at that point in time. Scaling vertically, there's limits. There are only so many CPU cores you can put in a machine. And then even then, this was a particularly poorly designed application, so it wasn't even necessarily CPU cores. It was just, outright gigahertz being a bottleneck. So they changed the app around. They actually decided to split it up with the front end and the back end, which is fantastic, great. Let's get with the times for the late 90s, and so they took their front end and threw their front end up on the cloud. That's awesome. That's great. Allows them to scale that front end component quite a bit more than before. And then they took their back end, put their back end in the containers so that they could actually scale that out a little bit more rapidly as well. So they went live. Everything looked great when they plugged, when they basically plugged it in and turned the switch. But then by noon, everybody was unhappy, right? Everybody was unhappy. They had 25-second response time. And then, one of the things that we do that we like to track is the bounce rate. So that's, basically a user coming into the system searching for something, and then whether they actually buy something or not. With APM platforms, you have the ability to track that. And they found that over 60% of the users were actually bouncing out of the system. So that's obviously not a good place to be, right? So what went wrong? And this is where things start to actually get kind of interesting. So they had a very small, it was a kind of a reasonably sized application payload, but you had a 26.7 second load time. But this is one of the things I really like talking about this one, because while this example is not strictly speaking a microservice with, it's basically just front end and back end, but we've run into issues with our customers where they end up committing architectural violations, right? This is an example where that's not supposed to happen, right? Your front end isn't supposed to call directly into the back end database, right? Front end is supposed to call into the back end is supposed to call into the database, right? And then obviously in this particular example, those machines are out there in the cloud, right? So those machines aren't in the data center, but the database is in the data center. I don't even know why they had the database ports open. It's even if this is a secure link between the public cloud, like a leased connection between the public cloud and their data center, that's still just not a good practice. And then the other thing that's kind of crazy is if you look at these counts, right? So this is on a per transaction basis. So every one transaction into the front end resulted in 33 service calls into the back end that was sending 99 kilobytes over the wire for every request. And then all of those calls into the back end here, you had 171 SQL statements. I mean, that's just getting ridiculous. So kind of the punchline for this is actually something that I gave a version of this slide at the Cloud Foundry Summit a couple of months ago. It's basically, crap in, crap out, right? If you're committing really bad code at the beginning of your pipeline and you're not checking it along the way, you're just going to get crap coming out the other end, right? So when we start to build these pipelines, all this automation is great. It's fantastic. We're doing a really great job. But if we don't start implementing more quality checks along the way, we're just improving our ability to make, nice, neat piles of stuff you'd put in your garden. So going back to this customer example here, right? So I actually want to go like that. I don't like clicking through everything. I like it all to just be there. So they kind of realized that as they went through and redesigned their application, that trying to bring 10-year-old code and third-party software all together without having really great architects on board, and when they start to move things over the services and things like that, there's a lot of different pitfalls and things like that along the way. So when they started to actually make those changes that they found out by starting to implement some performance checks along the way, they found that they were able to shrink that response time back to 2.5 seconds. That's decent. I mean, nowadays you really want to try and actually be a little quicker than that. But it was that 5K payload. And now instead of having a 99K payload back and forth between the front end and the back end, that's back down to 5K as well. And instead of having 33 service calls, now we've got one. And then one other key thing to remember here as well is, once again, I can't emphasize this one enough. There's no silly call from the front end into the back end database. So let's talk about lessons learned. All right. So this is where we start to get into, how do we start to implement some of these things, right? Another little funny anecdote. I was trying to find a replacement for this picture because I've been using this one for a really long time. So I was trying to find a funnier one, and I Google searched. I really like XKCD. Does anybody else here read XKCD? Yes? All right, awesome. So I was searching XKCD lessons learned to see if, because they've made comics about just about everything you can think of. And they came up with one, and one came up, but it was about rocket scientists, and it wasn't as work safe as I would like. So I'll leave it up to everybody to Google this on your own time. I didn't end up using it, not because of swears or anything like that, but the content just wasn't appropriate. It wasn't what I was going for. I like to push the boundaries, but that was pushing things a little too far. All right, so lessons learned. If you get one piece of information out of this today, measure all the things, right? Everything that you can measure it. And if possible, use it as gating criteria, all right? So how do we build and deliver apps like the unicorns? Well, we use a metrics-driven pipeline, right? And there's a whole bunch of different places that we can start to bring metrics into this process. So your developers and your testers, well, check in better code by instrumenting your unit tests, right? If we're not doing TDD, that's kind of sort of okay. But if you're checking in code without unit tests, that's no. Just don't do that anymore, please. So, and then better yet, use something like an APM platform or a profiler or something like that to collect performance metrics from your unit tests, because otherwise your unit tests are basically being wasted. All right. So then we got a couple of other places to start collecting some information. So in your CI process, you're going to use these metrics to stop builds before they go through the pipeline, and they'll just kind of get fed back into dev to get resolved. And then obviously one of the things that I was mentioning earlier is you want you want to be using a relatively similar tool stack across your life cycle. So just because you're collecting all this performance information, you're doing great performance testing earlier in the life cycle, that doesn't mean that you shouldn't be utilizing that same practices in production as well. And then once again, the same thing that was mentioned in the talk earlier today, going through these processes up to and including the performance validation, that's ensuring that you're having production ready checks. So this is really referring more towards doing things like validating your synthetic monitoring. I'm not sure if anybody's familiar with synthetic monitoring at all, but basically that's, Dynatrace has products like that. You also have things like, PingDom and so on. And basically you have robots that are pretending to be users. And the idea here is just to make sure that you're validating that in the other environment as well. And then obviously the other thing as well, going back to some of the things that teachers said, right? I think he actually gave a version of that talk as a webinar for Dynatrace. You also want to be monitoring business-specific metrics as well, right? So by having something like an APM platform involved that allows you to see method arguments in your production system and things like that, all that information, the whole idea here is continuous feedback. And continuous feedback is driven by both performance metrics from a code and system perspective, which we're all probably a lot more familiar with. There's also performance metrics that are going to drive the business as well, right? So when you're doing, your A/B testing, right, or maybe your blue-green deployments or something like that, if you send 10% of your customers to one version of the application, well, track the revenue that's coming out of that application and make sure that you have the ability to segregate that revenue from the other revenue. So if you made a code change, right? And remember that a deployment might be a marketing related deployment as well. It might be something as simple as a font change. And if that results in a significant drop in conversions, well, maybe that's not a route that we want to enable for the entirety of all of our customers. All right, I got 10 minutes. All right, I'm going to blast through this one here because this is kind of an example of the ability to be capturing this information in the early stages of your pipeline, right? So when you're actually doing a unit test, most people don't think of capturing any performance data from a unit test, but basically some of the information that you can get here is going to be really valuable because in this build everything is reasonably okay, right? But you have a relatively large number of SQL calls here for these pieces of functionality. This is actually going to be really hard to see. But basically, the whole idea here is this is telling a story of somebody commits a code change for build 25 here, and now instead of having one API call, now you have 34 API calls. Instead of having 35 SQL statements, you got 171. And instead of being a relatively small payload, now your payload is way larger and it's really slow, right? So this is something where, normally, generally speaking, we actually want to be doing performance tests in an environment where we're executing a very large number of requests so that we have statistically significant results. But what's really new about this is to actually use that same technology to actually pull the information out of your unit test, but really to be looking at key measures that are going to help you make a go, no-go decision on that release. All right, so let's start to talk about some of the information that ends up getting captured here. I actually want to skip this one. So when you look at there's a couple of different test types that can be done, a couple of different tools that are involved. I'm not sure if anybody here is responsible for doing anything like the Selenium tests or anything. Yes? So, I'm going to touch back on this again in a moment or two. But so when you're capturing all these metrics, what you want to do is you're actually building a corridor of what's acceptable automatically. So that helps you to, understand that in these types of environments, there's not a large number of requests. So you're not going to have results that are going to be statistically significant such that you're going to be worrying about 0.001% differences. But you still want to understand what the reality is for that environment so that you can stop a build when you've exceeded that corridor. And then this is actually just a really cool thing. This is actually something we use in our development offices. It's the UFO, and we've got the whole thing up on GitHub, including the files for a 3D printer, so that you can actually 3D print this, as well as all the Raspberry Pi code to actually drive all the lights. So what this does then is this actually takes the build status from Jenkins and displays it on the ceiling above all the developers, so they know at a glance what the current health of the system is. All right. So obviously here, you basically you're looking at Jenkins, where you start to see your test results. This is basically some of the things that Capital One was doing. They actually built this really cool tool to visualize Jenkins data across multiple applications. All right, now here's where I want to actually get. So here's where you want to take pictures. So this is just a couple of examples of some of the things that you want to be looking at. So when you're validating your performance, you are looking at a corridor, because once again, you're not going to be quibbling over small percentages. But the N+1 problem still happens. It's been how many years of ORMs and so on, and we still run into the N+1 problem, where instead of where you're basically iterating over a record set one by one by one by one by one. Now the same thing is actually happening in microservices as well. So you mentioned earlier, like they actually gave a really great example upstairs of how you should do things, because you had like basically a get user and then you had get users, and those were two separate functions, right? There's a lot of folks that actually don't do that, and then you end up having to, if you're returning information on 60 users, you're just getting that information 60 different times, which is crazy. But obviously, as you start to work with more and more frameworks, Spring is awesome, but every once in a while, all these frameworks are going to give you exceptions, and no exception is free, right? There's a performance cost to having exceptions. So maybe you're going to have a couple of them, but it's always good to make sure that you don't exceed your corridor. And now we've got 5 minutes. So, and then obviously, once again, the architectural validation is one of the key steps here. So here's an example. Let's get through this stuff here. I actually wanted to show something here in a second. All right, I'm not going to talk about that. I'm going to skip it. All right, so then the other thing is, once again, I mentioned synthetics. So synthetics are going to give you that ability to track whether or not you're up or down, right? So if you actually deploy something and then your availability drops to 0%, that's not the greatest thing in the world. In fact, that's actually the worst thing in the world. And then obviously having that perspective of what's happening on the user side is really important as well, because once again, we're continuously providing feedback to drive those decisions. And sometimes poorly performing code doesn't just mean it's slow, it means that maybe the users can't use it. All right, so I want to actually get out of PowerPoint here and make sure I go through my 4 or 5 minute Jenkins example. All right. And can everybody see that okay? All right, it's not too much of an eye chart. So the basically what I have here is I have a, is anybody working with Cloud Foundry and actually deployed Spring Music? He has? All right, so I used to be a Hadoop guy, so Spring Music is basically my Cloud Foundry equivalent to like a word count, and I see it in my sleep, for better or worse. So basically it's a very simple pipeline, but Jenkins gives you the ability to actually link workflows together. So the very first workflow, since there's no unit tests in Spring Music, which I actually found really surprising, considering everything that Pivotal talks about, there's no unit tests in Spring Music. So there's not a whole lot happening in this Jenkins workflow, but if we go to the next workflow, here's an example of, so obviously assuming that build took place and my artifacts were generated successfully. Now I'm going to configure that. So basically what I do here is, assuming that the previous build was successful, so my artifacts actually got built. What I'm going to do is I'm going to use the plugin to tell Dynatrace what build we have here. All right, so what's the build information for that release?
You could zoom that in a little bit.
Is that Command plus?
Yeah. There you go.
All right. All right, so that's not as interesting, but as we scroll down here, so basically Dynatrace has got a great little plugin so that we can actually kind of track that information. So we're taking that jar that was built earlier, and then we're basically using Dynatrace to say, hey, we're going to execute a test. And then since Jenkins has the ability to run things at the command line, what I'm doing here is I'm actually running a JMeter scenario that actually has some special information built into the headers from Dynatrace. That's not going to be real easy to show you guys on these screens, but I can provide all the samples later. And then the plugin is automatically going to fetch the data from Dynatrace so that it could show that little graph that you saw when I was on the screen earlier. And then I have the ability to modify the build status based on that information, right? So if it was a degraded test, if something went wrong, we can basically fail the build. But if you're just kind of getting started, maybe you don't want to actually fail the build on performance information yet, that is a capability that's available. You can collect the information, but not make decisions on it. And then here is an example of what the Cloud Foundry plugin for Jenkins looks like. So I'm basically connecting into my, I've got a minute left, so I'm connecting into my Cloud Foundry environment, and this is basically doing the equivalent of a CF push. And Jenkins can pull from a manifest, but I elected to just kind of configure everything manually, since I am using the exact same jar multiple times to deploy it to multiple environments. So I'm actually using this to enter all that information. And then obviously then you have the ability to just define another service in that build action. So this is telling it to grab the Dynatrace configuration information automatically. So what will happen when this is all done is this is going to take that release that was built and tested, and now it's going to deploy it to stage. And then there's a very similar workflow that is doing the same thing. Well, that looks weird when it's super zoomed in.
Command 0 to go back if you want.
What was that?
Command 0.
Oh, Command 0 will take me back to default? All right. So this one's basically doing the same thing to go and, once again, execute against the stage environment, make sure that everything is okay there. And then once again, assuming everything is okay, then I'm going to take it up into prod. I'm actually refining this. I'm going to make use of blue-green deployments here in a bit. So if anybody is working on something similar to this, utilizing Jenkins and Cloud Foundry together to manage their pipeline, I'm really interested in collaborating. So mostly just because I want to start building this out into more complicated sample applications. So I'm going to be out at Pivotal's office in the Bay Area in a couple of weeks to work with a Pivotal employee on this. But if anybody else has any suggestions on a sample app that they could use, I mean, you got to saw a couple of nodding heads over there, but I'm sure you're doing this on your own applications. So I'll be around the rest of the day today to answer any questions. I think we're probably out of time because that last minute was about 4. But are there any questions?
You failed the build in the Jenkins pipeline.
Yes.
And so it's one option. The option you can also collect the data you mentioned.
Yes. So basically, if you're rolling this out, right, and you're actually looking at it right here on the screen. So if you deselect this, right? So now I've decided that I want to collect the information. So Dynatrace is going to have the information as well. I'm going to have the information in Jenkins. Command 0. So I have my chart, right? So I have my chart in Jenkins. Jenkins is actually telling me what those test results were. But what I am not doing then is I am not actually failing that build, right? So I can collect the information, but if I'm not ready to use the performance information as a gating criteria, maybe this is something that I want to use for my first half a dozen builds or something like that, maybe. And in fact, I recommend that you don't turn it on right away because Dynatrace takes about 5 releases to actually start to build that corridor, to have some statistical confidence on what that data is. So you probably wouldn't want to make gating decisions until you've actually built that corridor.
API is open because we are also using the HiGR dashboard from Capital One.
Mm-hmm.
And the API is open, so can we feed HiGR with the data from Dynatrace?
Yes, so it's actually great that you mentioned that. So everything that is populating this is all available via API. So the Dynatrace server has got some nice Swagger APIs. So that assuming that so you've actually used the pipeline to actually populate a test run ID, and that test run ID then is something that you can fetch those via an API. So oh, that's not good. So I got a little bit of that's because I actually forgot to give it the information that. So you have to give it a body, but basically there's a API that'll give you JSON, XML, whatever back again to say, give me all the test runs, and then there's another API to say, here's my test run, give me the build information. And I can actually show that one here in a second. And we're going to give no, I want this one. So, and this is, these APIs are literally the exact same thing that, the Jenkins plugin is actually doing. I'd have to go back over here and get a valid test ID. But anyway, so you get the picture. You're basically going to get a JSON payload back, or if you're a crazy person, you want XML, you can get that back as well. And then you have the ability to do with it as you may with that information. And then obviously it's in Dynatrace itself. If I go over here to Spring Music. And then I go to test automation and test results. So, and I gotta not say 5 minutes because you do 30 days. So basically, all those test runs are in here, and you can start to see the. My Mac is actually being weird on me today, but you're basically going to have all of that information up here as well. Basically all that build information is available here as well. So.
Mike, are you back in town in a month or so for the Dynatrace?
So I'm back. Well, next week. Next week is actually the Dynatrace user groups. So yeah, next week. So I will be in Montreal on Wednesday and then Toronto on Thursday. So that's next Thursday. Yeah. So yay Canada! The previous to these 2 weeks, the only time I had gone to Canada was I was in far northern Minnesota, and we were so close to the border. We're like, let's go to Canada. So we did, and then we turned around and we came back. So so that was my previous Canada experience. So
Pretty good, right?
yeah, I like it. I dig it. So well, are we still recording?
Yeah.
All right. Yeah, so we can stop recording now if that's okay. Yeah. So I mean, thanks. Because if this is going to go on YouTube and everybody's going to be commenting about my comments on Canada.